Okay, the other day, which one, Mercy, which one was the sound not working on? The one where I did law cosines, right? Okay, so I'm gonna do it one more time, sorry, because the sound wasn't working on the other video. So I'm gonna derive the law cosines. I'm gonna do it, it's kind of the same way, just the letters are just switched around a little bit different. So this is right from the book, from the pre-calc book. I've started, by the way, just in case you didn't know. She's the only one not paying attention. There you go. Whenever I did that, was it Friday? Okay, yeah. Well, the beginning of it. And then, yes, I might as well. At least I'll have record of it on the video. I'll try to go a lot faster than I did then. I changed the order that I did a couple things from the first time I did this. So, I don't know. It'll probably be so much better. And let's see, we got this, and let's label it. This is, again, this might be just slightly different, but it's really the same exact idea as what we did on Friday. Right, that little bit I'm going to put as X. Remember we talked about this? If that little bit right there is X, this whole thing is A, so what is this thing right here? It's A minus X. Everybody see that? All right. All right, I think everything's good to go. All right, so let's take a look at triangle ABD. So let's take a look at triangle ABD. By the way, what are we doing anyway? We're deriving, put deriving the what? The law of cosines. All right, so we're coming up with it. All right, so we take this triangle, split it up the way it's split up right now, and what we're going to do is come up with a formula so that we can solve for one of these sides. Actually, we can solve for all three sides. So I'm going to take a look at triangle ABD. So I'm only going to do all this work for just one of the angles, and then we're going to look at it and say, well, if it works for this angle, it's going to work for these other two. We did that again on Friday if you were here, but a lot of people were not, so that's probably good to go through this. So ABD, the D is right there where I forgot it, okay? So ABD, I'm looking at this left triangle right here, and oh, by the way, that red is H for height, okay? Now I think everything's on here. What we're going to do is write a little formula for this right triangle here on the left-hand side. So I got a C, I got an A minus X, I got an H. I got these two sides, I got this hypotenuse. So let's use the Pythagorean theorem and set it up with Pythagorean theorem. So here we go. You ready? So C squared is equal to what? A minus X squared plus H squared. See what I'm doing? Just taking this triangle here on the left, that right triangle on the left-hand side, that one right there, and I'm just setting it up as Pythagorean theorem. So I'm going C squared equals this leg squared. What's this leg? A minus X. So I square it plus this leg right here, which is H. I square that, and then I got that. Now I'm going to do a little bit of algebra. This thing is being squared. You should be able to do that in your head. Remember this? It's a perfect square. So we square this one, and then it's minus 2ax. I'm not going to talk about how we get that. You can figure that out. And this is plus x squared. And then you still got the rest of this plus h squared. Again, all this from using Pythagorean theorem with this left triangle. Okay? Now what we're going to do is we're going to take a look at this little triangle on the right-hand side. So now we're going to look at triangle ADC. ADC. And we're basically going to do the same thing with this triangle. Over here we did Pythagorean theorem. Over here on this little right one, we're going to do Pythagorean theorem. Everybody with me on that? So how am I going to start this off? I'll start off with the hypotenuse, which is b squared is equal to what? X squared plus h squared. That kind of helps us out a little bit because look, b squared is equal to x squared plus h squared. Look at the thing we did right above it. Do you see this? There's an h squared plus 8, or an x squared plus h squared. So what do you think I can do now? Instead of writing x squared plus h squared in this little formula, what can I replace it with? Makes it a little bit easier. Come on, play along. Okay, I think you guys just got your heads down and you're just writing stuff and you're not really thinking. I want you to think. I want you to play along with me here. If this is x squared plus h squared, look what I just did. I said that x squared plus h squared was equal to what? B squared. So what can I do? I can substitute the b squared in for this x squared plus h squared. All right? See how much more fun it is when you play along? Yes. All right, so let's write it. So c squared is equal to a squared minus 2ax. Where am I getting this from? I'm getting this from this. Okay, but I'm going to replace this thing in the box with a b squared. That's all I'm doing. It's the only thing I'm doing in this step. All right? Plus what? B squared. Everybody see that? All right, so that's not too hard. Pythagorean theorem with this triangle, Pythagorean theorem with this triangle. Okay, I did a little substitution because I saw an x squared plus h squared in both of them. So I just replaced this x squared plus h squared with a b squared. That's all I've done so far. All right. So what we are going to do now is this. And you're probably thinking, why would anybody even think of doing this? But they did, and it works out real nice. Okay. What we're going to do is we're going to solve for c. Okay. Well, we're not really going to solve for c, but I'm going to do something with that c. I'm actually going to solve for x, all right? And I'm going to replace this x with something else, okay? So I'm going to do another substitution in a minute, but I want an x in there. So what I'm going to do is take this. This side right here is the adjacent side to c, correct? And this b is the hypotenuse. And so what trig function uses adjacent and hypotenuse? CAH. Which trig function uses the adjacent hypotenuse? The cosine does, okay? Everybody got that? Sure. So let's write it here. So the cosine of this angle, right? And why did we do that? Well, we do it, like I said yesterday with the law of sines, we do it because it works, okay? It actually works out, and we can solve for x, and we can replace this x with something else. All right, and that's what we're trying to do. So I take the cosine of this because I got adjacent and I've got hypotenuse. So what is that? Cosine is x over b. What am I going to do? I want to solve for x. So I solve for x. Very simple step. Solve for x, I have to get rid of the b. The b is being divided. How do I get rid of something that's being divided? I multiply. So that goes away, and then I multiply that side by b. So what's x equal to then? It's equal to b times the cosine of angle C. That way I don't have any x in my formula, all right? All I have are my sides and my angles, all right? Because the x really isn't like one full side and it's not an angle. So I don't want the x in there. I want other stuff in there that has to do with the sides and the angle. And this gives me a side and an angle, doesn't it? So that's basically why we decided to do that. So what we're going to do is we're going to take this and replace it with that x right there. We're going to take that x out. We're going to put what it's equal to. All right, so we get c squared equals a squared minus 2a. Now, it's times x. What is x equal to? It's equal to b times the cosine of c. And then you got to write the rest of it as well, plus b squared. All right, we're getting there. A couple more steps and we'll be done. So what can I do to this? What can I do to simplify that? Well, I can take this negative 2a and multiply it by this parentheses. So really, I don't even need the parentheses. I could just go this. I can go a squared minus 2ab cosine of c. It's really all I did was just get rid of the parentheses, plus b squared. And we're almost done. All right? I don't like that a squared and that b squared being apart from each other. Okay, I want them next to each other. So here's what I'm going to do. And this is the law of cosines. Okay, this last thing that we write down is actually the law of cosines. So I've got c squared equals a squared. Let's take that b squared and put it next to the a squared. So it's still a plus b squared, and then we got minus 2ab and cosine of c. So that right there is our version of the law of cosines. That's it. Is this something you're going to have to do on a test or a quiz? No, I'm not going to make you do it, but I just think it's important, especially for students that are a little bit more upper level students, which you guys are. That's what I would, that's why I did that, okay, because I think it's important. I really do. I remember doing stuff like this in college. I don't remember any high school teacher ever doing, like, deriving a formula. But when I saw it in college, I thought, oh, that's pretty cool. That's where it comes from. I heard of that formula before, but I never knew where it came from. And it just kind of gives you a better appreciation for the formulas instead of just learning. I could have just slapped it up there and said, okay, this is what this means. This is how to use it. Thank you very much. Glad you came. Here's your homework. All right? But I think this gives you a better appreciation for the math. Maybe you don't think so, but I do. We could write it a couple different ways as well. We could have gone through these triangles. Instead of finding C right here, instead of finding the cosine of C, I could have done this angle right here. Could have found the cosine of B. And you would have gotten a formula. Then I could have found the cosine of A and did that whole thing. All right, everybody see that? Something's going on. I don't know what, but you got to pay attention. Be serious students today. You guys are being quiet, but I can sense there's something, some kind of communication, nonverbal between you guys. So let's take a look at this. Here's another way I could write it. Instead of c squared, I could write it a squared. But then what's the other stuff going to be? Now notice, this c is side c. This is angle c. The angle is opposite this side. So what do you think on this version of this formula you're going to have the cosine of? The cosine of what? Cosine of a. Okay? So if this is a, that's going to be a. So what if I wrote it in terms of b? What's this going to be? Cosine of what? How about b? All right, because it's opposite this angle. We already had the cosine of c up here. All right, so instead of a squared plus b squared, look, what did this leave out? It left out the c. So we're going to leave out the a. So what's left? B squared plus c squared minus, now this one says 2ab, or 2 times this number times this number. So what's this going to be? Minus 2 what? B times c. And that's another version of that formula. Hope you're watching. So b squared is equal to a squared plus c squared minus 2ac cosine of b. So those are your 3 versions of the law of cosines. They're really the same thing, okay? It just depends on what you name angle A, angle B, angle C. Really, I don't even memorize like these two. It's the C one that I usually, and most teachers have you memorize. Okay, that one right there is the one that most teachers memorize, or have you memorize, or learn, I should say. All right? So you could learn all 3, but really they're the same thing. They're the same thing. You're just replacing the sides. All right, enough of that. Let me just grab that so I don't have to write it again, copy it. All right, so let's do an example. Did we do an example of this on Friday? Can't remember. Doesn't matter. We're going to do one now. So here's triangle. We'll call this ABC. And again, it really doesn't matter. You can call it XYZ. You could still use the law of cosine formula. Okay? So this would be A. This right here would be B. And this would be C. And what do they give you? They give you angle A is 120 degrees. So here's the stuff that they give you. They give you that's 120. They give you side B is 9. So they give you that. And they give you side C is 5. So they give you that. All right, what they ask you to do is solve the triangle. You got to find all the missing stuff in the triangle. You guys going to pay attention to me? Let's be a serious class here. All right? I still see the goofiness going on. All right? I'm not oblivious to the fact that you guys aren't paying attention. Don't make me be like this, okay? Be a real student. You guys aren't being real students, some of you. Just being goofballs. Knock it off. All right. Hate to yell at my last class, for goodness sakes. I don't think I've yelled at a class today. That's the first time I said anything negative to a class, and it was you guys. I expect more. All right, let's do this. Let's find A first. And we're going to use the law of cosines to find it. So, you could go back and say, okay, what's my version of it? I'm solving for A, so you could use this middle version right there, A squared. So let's just write it down like that. So finding A right there. So let's write that down. A squared is equal to B squared plus C squared minus 2BC cosine of A. All right? And let's plug in the stuff. Don't know what A is, so I'm just going to write it as A squared. Equals B squared. What is the B? It's 9, so it's 9 squared. Plus C, which is 5. That's 5 squared. Minus 2 times B times C. It's just these two right here. 9 times 5. All we're doing is plugging stuff in. That's why I'm going so fast. The cosine of A. What's A? It's 120, so I'll put 120 degrees. Now, it's just plug and chug. All right? You just plug stuff into the formula. You got to know what you're putting in. Put it into the right formula the right way. Just put everything in here and then put that into a calculator. Now you've got to practice this, all right? I can't stress enough that you practice using your calculator. This is not that easy sometimes, okay? It's sometimes for some people it's not that easy. Depending on what calculator you're using, some might be a little easier than others. You've got to know how to do this in your calculator. I'm not going to go through and give you a calculator tutorial right now. I've done it before, right? I think on Friday. If you were here, there's no sound, obviously, if you just watch the video. But I got more to do, so I can't give you a tutorial. You got to know how to do this on your calculator. So you come out to approximately 12.3. So that's what A is equal to. All right, so let's put that on here in a different color. We got to solve for everything on this triangle. So this is 12.3. Well, we got some other things to solve for, don't we? Got all three of our sides. I got to find one of these angles. If I find one angle, the other one's super easy because I just take them both away from 180. All right? So you could find one of the other ones. Let's see. You could use the law of cosines again if you wanted to. Actually, I lied. No, you could. You could find this angle right here by the law of cosines. I'm not going to. They use the law of sines. Let's use the law of sines. But you can. There is an example that we did where I did it both ways, and you get the same thing. So you could solve for angle B using the law of cosines, except what's your variable going to end up being? This B. Let's do it. I talked myself into it. Let's use the law of cosines and not the law of sines. If you look in the book, in the example, they use the law of sines. I don't know, maybe I should, just so we practice the law of sines. Yeah, we're going to have enough practice with the law of cosines. I talked myself back out of it again. So let's use the law of sines. So I want to find angle B. So if I'm going to use the law of sines, I want to put the sine of B on the top. If you remember that from yesterday. Remember that? Over side B. What's side B? It's 9. Now I got to know an angle and a side. Even though this is an approximation, it's the only thing I have to use, okay? So I have to use it. All right? So what do we got? I'm going to put the sine of the angle. What angle do I know? 120. So I put the sine of 120 over side A, which is 12.3. See how I use the law of sines? Sine of B over B, and this is the sine of A over A. I know what angle A is. I know what side A is, so I put that there. I don't know what angle B is, so I just put a B. I know what side B is, a 9, so I put it here. The math is this. Multiply both sides by 9, so put the 9 right there. And then the sine of B is equal to all this stuff. How do I find what angle B is? I take the inverse sine. So I'm taking the inverse sine of this whole thing. So that's the sine of 120 over 12.3. Now this, again, practice. Okay, practice it. Because this could be a little tricky. This is a little easier, I think, than using the law of cosines, but make sure you practice this. That's all I'm going to say about that. You put it in a calculator and you should get 39.3 degrees if you round it to the nearest tenth. All right, so that's what this angle is right there, 39.3 degrees. All right, one more thing we got to find. What's the only thing we don't know now? Angle C, super easy, no trig, no law of sines, no law of cosines. Just go 180 minus the other two angles. 120 minus the one we just found, 39.3, and that gives you about 20.7. These are all approximations. I'm putting equals there, but they're all approximations. That's angle C, and that can go right here, 20.7 degrees. And there you go. You solved the triangle. You found everything in here. So that's how you use the law of sine or law of cosines and the law of sines in conjunction with each other to find all the missing stuff. All right? That's something you would have never been able to do before without knowing this. Okay? And I think that's pretty impressive. Let's do another one. So this is still the same example, but it's part B. So I'll put a B right here, whatever example that was. Now, here's what they do. They don't even give you a picture. They just say that A is 24. They tell you that B is 40. And they tell you that C is 18. Now, they give you a hint on this. They don't explain why to look for this, but they say to look for it, and it's a hint. And I'm not really sure of the reason why, but I am going to show you what they said. They said, if you look in the book, if you have the book open, it says something about it's easier. I don't think, they may not use the word easier, but that's basically what they were saying. It's more efficient or something if you know what kind of triangle this is. So I don't know if you remember from geometry, we taught it, and I taught it just having a test on it. We had a test on it today in my CP geometry class to tell what kind of triangle this is. All right? So how do I know what kind of a triangle it is? Well, if you remember this. Do you remember this at all? Oops. If C squared, C is the larger of the three. Okay, if C squared is greater than A squared plus B squared, what kind of triangle would that be? Anybody remember? If it's greater than. What's greater than 90? What kind of angle is greater than 90? It's obtuse. So what kind of a triangle would this be? If C squared is greater, it would be, no, it would be obtuse. I gave you the hint. Okay, I gave you the hint that an angle that's bigger than 90 is obtuse, and so it kind of follows, at least I thought, it followed that the triangle would be obtuse because this is greater than this. Right? They only give you this. This is something that you should have known from geometry, or they expect you to know. All right? So let's just see what kind of triangle this is, because they say finding the angle opposite, finding the obtuse angle, okay, would be the easiest angle to find. I don't think they use the word easiest, but they said it's the best one. I don't know why. They didn't explain why. I wish they would have, because I'm kind of curious. But anyway, you want to find out which one is the obtuse angle. All right? So first of all, it's an obtuse triangle, right? We know it's an obtuse. How do we know it? Because if I take C squared, what is the C? It's not this C right here. This is the longest side. This is the other two sides. This represents the longest side. Which one's my longest side here? It's 40. So I go 40 squared, and I compare it to the other two sides squared. Again, the A, B, and C might mess you up a little bit here, but the C represents the longest of the three sides. All right, so that's the 40. The A and the B are the other two sides. So that would be 24 squared plus 18 squared. I'll do the math for you. It's 1600. That's easy. You could do that yourself. And this comes out to be 900. So 1600 is greater than 900. So what kind of a triangle is this? It's obtuse. All right. So the obtuse angle is always opposite the largest side. So the largest side is 40. So which angle are we going to solve for first? We're going to solve for angle B. So let's draw it. They didn't draw it for you, okay? I like to draw it. You could probably do this without drawing it, but man, I wouldn't want to. I like to see it visually in front of me. All right, so B is 40, so this would be B. All right, this is the shorter one, so that would be C. This would be the longer one, this would be 24, so that would be A. All right, and let's put the letters in here. That's the angle. So if this is side B, this is angle B. If this is side C, this is angle C. If this is side A, this is angle A. All right, they didn't give you that. All they gave you was this. That's the only thing they gave you. And they want you to find angles A, B, and C. That's what they want you to find. Everybody with me on that? Okay, so, and again, they gave you this hint to find the obtuse angle first. That's why we went through this stuff. So this is the obtuse angle. That's the one that they suggest that you find first. I don't really understand why, because I think you can still find angle A, you can still find angle C first if you wanted to. I'm not really sure why, but that's what they said to do. So that's what we're doing, all right? So if I want to solve for B, now I can use the law of cosines. Because I know these two sides, I know this side, I just don't know this angle. Now watch the math that's involved here. Let's set it up first. So this would be B squared. So what are we going to do? We're going to go B squared, right, equals A squared plus C squared minus 2AC cosine of B. All right, remember we had those three versions and I put them in boxes. This is the one we're going to use because we're trying to solve for B. So this is what we're solving for this time, not the side B. They tell us the side B. So let's plug some numbers in. B squared, so that's 40 squared. Don't write that down as a number. Don't put 1600, okay? Just keep everything, just plug the numbers in, and then we're going to do some math with the numbers the way it is. So what is the A? That's 24, and then squared, plus C, which is 18 squared, minus 2 times 24 times 18 times the cosine of B. And that's what we're trying to solve for. We're trying to do some math to solve for B. At first, this is a little bit complicated, but really, I think it's kind of simple-ish, okay? Ish, all right? So let's get B by itself. So what are we going to have to get rid of? We got all this stuff we got to get rid of, all right? So first of all, let's get rid of the 24 squared. It's being added, so is the 18 squared. So how do I get rid of something that's being added? I subtract. So I got a 40 squared over here to begin with. I got to get rid of this. How do I get rid of that? By subtracting a 24 squared. I got to get rid of this. How do I get rid of that? Subtracting an 18 squared. Now I have to get rid of the negative 2, the 24, and the 18. What are all three of those things doing to each other? They're multiplying. How do I get rid of stuff that's being multiplied? I divide. So I divide everything by negative 2, 24, and 18. I don't have to show it. I know they're going to go away. It's just a waste of time as far as I'm concerned. But on the other side, I definitely have to show it. So what am I doing? How do I get rid of that negative 2? Divide by negative 2. How do I get rid of that 24? Divide by 24, divide by 18. So I got rid of this, this, and this. So what do I have now? I got the cosine of B is equal to all this. It seems like a complicated step, but it's pretty easy. I just subtracted a couple things, and I divided 3 things. That's all I did, all right? Didn't even do any arithmetic yet. I just moved everything to the other side. That's all I did. Now, if I want to get B by itself, how do I do that? Take the inverse of the cosine. So technically, it's going to look like this. It's going to be the inverse cosine of all this stuff. And instead of writing it out, I'll just copy and paste it. Okay? So this is what you're putting into your calculator. You might think it might be easier to actually figure out 40 squared and then 24 squared and then 18 squared. I don't think so. I think put it all together in one big old pot, right? And then okay, do your calculator all at once instead of bringing everything down. And then once you do that, again, you need to practice this. You're going to get 144.1 degrees, approximately. It's not exactly, I wrote exactly, but it's approximately. So angle B is 144.1 degrees. Now we got to find angle A and angle C. I decided to find angle A next. Don't know why, probably because the book did, all right? So, but you could have found angle C next if you wanted to. You could use the law of sines or you could use the law of cosines. Which one would you rather use? Law of cosines or law of sines? Which one? Anybody have a preference? Nobody? Law of sines? Okay, let's use the law of sines again like we did. Did we do that on the other one? Yeah, we did. So let's use the law of sines. So again, let's go back up to here. So now we know this angle, don't we? This is, what I say, 144.1? Yep. So that's our angle. So now if I'm going to use law of sines, I got these two, and I can either solve for A or C. Angle A or angle C. Let's solve for angle A, since that's what I did. All right. Yeah, I'll just do it right here, since I got the picture right there and we can see it. So I want to solve for an angle. So I'm going to put the angle on top. So I'm going to go sine of A, put that on top. Everybody understand that? I could have gone A over the sine of A, but since I'm solving for angle A, I'm going to put that on top. Over side A. What's side A? It's 24, isn't it? You guys aren't helping very much. I'm just doing all the talking. So sine A over this. And then what do I have to do now? Now I got to know both of these. All right, so I know both of these. I know this angle, I know that side, so let's do that. Let's go sine of angle B, which is 144.1 degrees over side B, which is 40. All right, let's do the math again. Same thing that we did on the last one. Multiply both sides by 24, so put the 24 right there, and then get A by itself. So when we get A by itself, it's just the inverse sine of all that mess right there. I won't rewrite it just because of time. And then you do all that and you get 20.6 degrees. 20.6 degrees. Once you got that, then it's clear sailing from here on out. You only got one more thing to do. So there's that angle. How do I find this angle C? Super easy. What do? Take them away from 180. Very good. Got a little feedback there. That's good. So 180 minus 144.1 minus 20.6. That's super easy to put in your calculator, and you get about, this is angle C, by the way, you get 15.3 degrees. You need to practice this. Don't just sit there and watch me. Okay? Don't even just write down the answers. Okay? Even if you're taking notes on this. Don't just write down the answers. Actually, do this yourself on your calculator. All right? You need to practice this on your calculator. I can't stress that enough. I've seen so many people be able to actually put the formulas together and then screw it up when they put it into a calculator. And you're going to get it wrong. All right? Even if I saw, and I hate to do this, but even if you wrote all this correctly and you messed up on your calculator, I'm marking it wrong. Because you wouldn't want anybody that's building a bridge to do all the work right, and then they put it in the calculator, get some crazy answer, and the bridge comes falling down. Would you? No. All right? The answer matters. Wouldn't you agree? If you're driving across a bridge, if you're in a house, right, and all the stuff has to work, so hopefully it doesn't fall down. So make sure that you're able to do that. Okay, I got another thing to do. All right. I know it's not the most exciting stuff in the world. I don't know. I like this. I like law of sines, law of cosines. I think it's pretty cool. But I'm a geeky 60-year-old man, you know. So what else I got to do, right? Right, Mr. Hamrick. You guys are dead today, for goodness sakes. I don't know if I'd rather try to keep you guys calmed down or try to get you pumped up a little bit. I don't know what's worse. Thought you'd talk to me a little bit today. All right. We're going to go and do something a little different. We're going to find the area, okay? We're going to find the area of something. I think I'm going to skip example 3. I don't know, maybe, let's see, 8 minutes. Maybe I'll do example 3 tomorrow. No, better do it now. All right, here's what we're going to do. We're going to find the area of a triangle when you know all 3 sides. All right, so here are the sides. A is 4, B is 7. Now remember, this time we're not just solving for we're not solving for the angles. All right, that's what we did the last time. This is different. This is completely different. But we're still going to do a little trig stuff. Now, I don't know if you remember, but if you look back on the law of sines, look in your notes, look at the video, whatever, if you go back and look at the law of sines, we had 3 different forms of the area of a triangle. I don't know if you remember this, but we did it just a few days ago. Or was it yesterday? No, we did. I don't know. Maybe it was yesterday. Did we do that yesterday? Maybe it was the day before. I don't know. Anyway, we did this. I look back on it. We did this. So the area of a triangle is 1/2 BC times the sine of A. All right. So we have a triangle. Let me just draw it out. They don't draw it for you. They just put these numbers here. But I'm a visual person, so I like to see what's going on. So A is 4. B is 7, that would probably be this one, and then C is 9, it's probably this one, all right? So that would be angle C, this would be angle A, and this would be angle B. All right, so I want to find the area of this triangle, okay? Find the area of the triangle. Usually we go base times height divided by 2, but do I know the height of this thing? No, I don't, all right? So I got to figure out another way to do it, and we use this. This is something that we learned. It was either a couple days ago, I think. So look back and you'll see this. So if I want to find the area of this, I got to know 2 sides and an angle. The problem is with this, what don't I know? I don't know what? I'll answer since nobody's talking to me today. An angle. You don't know an angle, do you? You know 3 sides. Are you guys trying? Are you trying to participate? I don't think we are. All right, I'll shut up about that. Let me keep talking. I'll just pretend nobody's here, okay? Make life a lot easier for me. So I don't know the angle, right? I don't know this angle. I know all 3 sides, but I don't know the angle. So I need to find the angle. So I got a couple things that I could probably use. Okay, one thing would be the, let's go law of cosines, right? I couldn't use the law of sines anyway because I don't know any angles whatsoever. I need to at least know one of the angles. So use the law of cosine. So let's do it. So I've got 4 squared, right? A squared equals b squared plus c squared, which is 7 squared plus 9 squared, minus 2 times 7 times 9 times the cosine of angle A. And we do the same math that we just did a couple minutes ago. So let's do it. 4 squared minus 7 squared minus 9 squared. Watch how easy the math is once you realize how to get rid of this stuff. Subtract both of these, divide by this. Negative 2 times 7 times 9. Okay, take the inverse cosine of this, and that's what A is equal to. Okay, so A, angle A, will equal all of this. Put it into a calculator, and you get 25.2 degrees. Practice that on your own. So now we know an angle. Okay, so now I know angle A, which is 25.2 degrees. So now I can actually find the area of it. So what is the area? Well, here's my little formula right here. It's 1/2 B times C, so it's 7 times 9 times what? The sine of angle A. We just found angle A. That's why we had to do this, so we could find angle A. That's why this is in the law of cosines section. Plug all that into your calculator and you get about 13.4. They don't give you any units, but we'll just call it units squared. So that's the area. So the area is equal to 13.4. So that's something that they're probably going to give you. Let me show you something super quick. It's pretty easy. They call it, now this book, actually this guy's got a couple names. I teach out of another book, and I've taught out of other books where I've seen the word Heron, H-E-R-O-N. So it's Heron's formula, or this book, and I looked him up on Wikipedia because I didn't know anybody. I didn't know anything about this guy. Sometimes they call him Hero. I guess it's called Hero. Hero's formula. Same dude, all right? He's an old guy. He's Greek, all right? Don't leave. Why are we packing up? I'm not done. Man, I'm a pain in the butt today, aren't I? I don't care, because you're not acting like honor students. All right, watch. Here's your formula. Have we done this formula before? I know I did it in one of my classes. Don't know if I've done it in here. We did it in geometry? Okay. So what is the S? The S is the semi-perimeter. Don't leave. The bell's going to ring. I want you to stick around since you haven't been nice to me today. So this S is the semi-perimeter. This, the A, B, and C are the sides of a triangle. So here's what they're going to give you. I'll just do it sloppy and fast. Here we go. This is 72. This is 83. This is 95. And I want to find the area of this triangle, okay, without doing what we did before. We could do what we did before, all right, but that was too long. This is one simple little formula, and we can find the area of it super easy. You could try this formula with the other problem that we did and see if you can get the same thing. Semi-perimeter, what is that? It's half of the perimeter. So what is S? What is the semi-perimeter of this thing? Well, it's 72 plus 83 plus 95. That's the whole entire perimeter, but then what do we do to that? Divide it by 2. And so the semi-perimeter, if you do the math, is 125. So it's 125 all around the whole thing. Now it's super easy. S is 125. What is this? S minus A. That's just 125, 125 minus one of the sides. I don't know, doesn't matter which one, 72. Let's take that 125 again and subtract one of the other sides. What's one of the other sides? 83. And then we take that S again, 125, subtract the third side, which would be 95. Do all that in your calculator, and you get this big old number, 2889.2. It's area, so it's units squared. And look how easy it was. We didn't have to do the quadratic, or the, not quadratic, what is it? The law of cosines, and then all that other stuff, okay? You could just use this. This is when you use this when you know just the three sides. You don't know any angles, all right? You just know the three sides, and you can find the area of that triangle just knowing the three sides. All right, so law of cosines, that's 11 to 24 for homework. 11 to 24 is your homework, and it's section, I don't know what it is. What section is this? 5.8. Section 5.8. All right, there you go. 11 to 24, that's homework. That's due tomorrow. Did you have another one that was due today? That law of sines? We'll go over both of those tomorrow, okay? That's tomorrow, just be going over homework, okay?